Hello Math 30-2 and welcome back. Today we're looking at lesson 2 of polynomial and sinusoidal functions. So we're not going to quite get into a sinusoidal yet, we're still going to look at polynomial, except now we're going to look at degree 3, which are called cubic functions. That means my largest degree, or my largest exponent, is 3. Not negative 3, but positive 3. Okay, if it's negative 3, that's no longer a cubic function. So it is 3, positive 3. That's what we're looking at when we say a cubic function. Now if we're looking at these here, I have two types of cubic graphs. We have one that goes like this, and then one that goes like this. If we notice this first one here, there's two humps in it. It kind of goes up and then down. This one here, it just goes like this. It changes direction, okay? And that all depends on the factors of these graphs. But we're not going to get too much in detail on that. We're just going to focus on this part here first. So if I look at this point A of this cubic equation, or cubic function, this point here is a maximum. It's like a mini maximum. We go all the way up, and then it hits a max, then it decreases, okay? So we have a maximum turning point. So it goes all the way up, and this is my maximum hits, then it starts decreasing till we hit a minimum turning point. Because this is a minimum, goes decreases all the way to here, then goes back up. So we have one little mini maximum and a mini minimum. So this is a maximum turning point and a minimum turning point. And what makes each a maximum and minimum is we keep on going up till we hit a limit, and then it starts going down. So this graph here has two turning points, one maximum and one minimum. Now let's take a look at the second graph here. Notice how it goes nicely like that. This graph here has something called an inflection. This isn't really a max or a minimum. It goes down, then it slows down, and then speeds back up. This point of reflection determines how the graph curves. Here's curving this way, then all of a sudden it starts curving the other way. So that there is a point of inflection. These are three definitions I strongly suggest you do. Point of reflection, though, is not a turning point. It is just telling you where the curve changes. All right? Okay. So here we go. Now, this part here, I'm not going to do all of it, but I really want you guys to try and do this the best you can. So basically graph each of these equations and try and answer these. Answer these now, pause the video, do it at home, and answer these. And then in class, you're going to spend 10 minutes in your group seeing what each other got and then trying to help yourself create rules, okay? So I really strongly suggest you do this and spend 10 minutes trying to solve this and graph each one. And while you're doing this, I want you to look at this. Notice this here has one root, one factor that we could take out, and then the rest is a quadratic. This one kind of has two factors. These factors are the same. This one here has three different factors. These do play a key role in something. These factors, this, and this, each do something. I want you to look at each graph, see what do these mean. Those actually mean something along here. So pay close attention, then we will get to this again tomorrow. Alright, so here's the next part. The next part we're going to be looking at, I'm just going to do the this one here for you, or the first two for you. That's it, okay? And what they look like if you graph them. So if I was to graph this one here, I kind of already know what it looks like, x cubed, because I've done this one quite a bit. At the end of the year, you'll figure out x cubed very fast as well. So it kind of looks like that if I was to graph from a calculator. What is my domain? Well, this is one thing we'll look at. My domain goes forever left and forever right. So my domain is x is an element of all real numbers, because x could be any real number. I can't say x is a number of all real numbers, it doesn't make sense. I say x is an element of all real numbers, so it belongs to all real numbers. My next one here is my y, my range. Well, it looks like already, looking at this, it goes forever up and forever down. So y can be all real numbers. So y is an element of all real numbers. Now, how many x-intercepts do I have for this one? This one, I only have one x-intercept. How many y-intercepts do I have for this one? Or what is my y-intercept? For this one, my y-intercept is 0. When x is equal to 0, crosses my y-intercept. Or my y-intercept is at 0. Okay, it's at 0. Okay. Next one says the number of turning points. So number of turning points. Well, this one doesn't have a turning point. This one has an inflection point. So I have 0 turning points. Okay? Then it says left tail starts in which quadrant and right tail. So my left tail is right here. It is in quadrant. If you remember, it goes 1, 2, 3, and 4. So my left tail is in quadrant 3. My right tail is in quadrant 1. So left tail, because left it that way, it's that way. Right's in quadrant 1. Okay. So let's take a look at my next one. This is just negative. So that means everything that was negative in y is now positive, because we have that negative in front of it. So it's like x cubed, except all my y values that were negative are now positive, and all my negatives, or I mean all my positives are now negative. So it's just going to look the same thing, except it looks like that. Something like that. Okay? So my domain, same thing. X is an element of all real numbers. My range, y is everything. My x-intercept, well, there's 1. My y-intercept is 0. Because even if I look at this, am I adding anything onto this? Remember, my y-intercept when x is equal to 0, when x is 0, 0. This one here has a y-intercept of negative 20. Hey, this one here is 2, negative 6. It's so easy to do. Next is my number of turning points. Once again, this one here has how many turning points? This one has 0 turning points. Okay? And the left tail is, well, way over here. My left tail is going to be in quadrant 2, and my right tail is in quadrant 1, or in quadrant 4. So I take a look at that. This negative kind of changed my quadrants, didn't I? Just like my left and right tail in the lesson before. It changed my quadrants when I looked at quadratics. That's interesting. I wonder if that will change for this one, which one this one will be. So I want you to keep in mind of that, okay? And I want you to keep on looking at this here. Now remember, if we have more turning points, the number of turning points depends on this. So if my graph does go like this, I'm going to have 2 turning points. So I'm going to give you time, pause your video, and try and finish this off, and compare with a partner. Alright, here we go. So characteristics of degree 3. So every polynomial of the function has a domain and range of what? So my domain is, so every polynomial that's a cubic function has a domain where the x is an element of all real numbers. And we have a range where y is an element of all real numbers. My number of y-intercepts is going to be, no matter what, I'm only going to have one y-intercept. I can only intercept once. So that's something that, these are just kind of rules that we could go over that we found out by doing all these lessons. So the next one says, the graph of the polynomial function degree 3 has either 0 turning points or 2. Because it either has a minimum turning point and a minimum and a maximum and minimum, or minimum maximum turning point, or it has what's called that inflection point. Those are our 2 kinds that we could have. An inflection point isn't quite a turning point. So now, how many x-intercepts could there be? Well, that actually relates back to, remember I told you to keep an eye on these here, and what this meant? That relates to how many x-intercepts there are. So we could have 1, 2, or 3 x-intercepts. Okay? So now it says the end behavior of the graph, and so we're just going to use the word up and down. Okay? In each blank space. So the leading coefficient is positive, then the right tail of the graph goes. So if the leading coefficient is positive, the right tail, that's all the way that way. So my right tail is the one here. If it's positive, my right tail goes up. And my left tail, which is down here, because if it's going to look like this or something, it's going to be going down. Okay? My leading coefficient is negative, well, then my graph is going to look something like this. Right? There's going to be a little loop-de-loop there. So if it's negative, the right tail is down. This is my right tail, it's going down, and my left tail will be going up. Okay? So let's consider left to right. So if the graph starts in quadrant 3, so quadrant 3 is down here, and ends in quadrant 1. So this is going to be an increasing graph, so this must be a positive. My leading coefficient must be positive. The next one is the graph starts in quadrant 2 and ends in quadrant 4. So we start here, quadrant 2, and ends in quadrant 4. That looks like this one. This is if it is a negative coefficient. Okay? Now, what do these degrees remind us of? Is it a constant function? Well, a constant graph looks like this, or like this. No, this is definitely not constant. Those are just straight lines going across. Well, what about a linear function? A linear function either goes like this or like this. Well, it starts and ends very similar to these cubic, doesn't it? So far I'm going to say linear. What about a quadratic function? Well, quadratic functions are either happy face or frown face. So it starts and ends completely different. So it's most similar to a linear function. All right? Okay. So now here it says, in the last question, part 3, students were asked to graph this equation. So you're asked to graph this equation using that window. So I'm just going to set up that window in that equation right now. So it says -8, 8, 2, -20, 25. Okay, and what are we graphing? 2x to the power of 3. Oh, 3. And I want 2x to the power of 3 plus 10x squared. And I want plus 6x, whoops, 6x. And then I'm going to subtract 5. I'm just going to look this up here so you can see it. And then I want to subtract 5. Okay? Enter. So there's my... Oh, that doesn't look right. I have 2 to the power of x there. Six. Get rid of that x, that 3. There we go. Oh, why is it to the power of x? I'm going to delete this, delete, and insert x. There we go. So now that's it. So I'm going to graph it. And my graph looks like this. There we go. So even I make mistakes a lot of time, which is okay. So I graphed that one. Now it says, Kevin entered one of the digits incorrectly in his calculator and graphed this on the display. Is shown. So how can you tell that the graph displayed on his calculator does not make that following characteristics? Well, first of all, if I look at this, it's forever up and forever up. That means this looks more like a quadratic. So then this here might be, so it doesn't start and end where it should be. So it should start, if I look at this, it is positive. It should start in quadrant 3. In 3, and end in 1. But it doesn't do that. So that's one thing where he knows automatically he made a mistake. So that's the first thing. Okay? So a graphing calculator window will allow the main characteristics to be seen and sketch the graph grid. So it wants us to write a graphing calculator window that will allow the main characteristics of this graph to be sketched. Well, right here, the graphing calculator window works. So according to this, let's just do exactly what they have there. And also, if we look at this, I think in this one he did 10 and 10. So I'm just putting everything in, or zoom. Oh, it's just waiting. So basically, we have to make the window. So as soon as we see this and there's not enough room, well, I can't see the humps. If we know, we double check, we know that's put in right. I can't see the humps, so that means if I can't see the humps, that means like right here I'm missing some humps. That means I have to extend it. If you see mine here, I'm missing, so I have to extend it up. So I'm going to extend my y to 20 and get my humps in there. There we go, and it's fairly narrow. I could expand it. So that's kind of the idea of it. So a good window would be kind of like what they have there. I would even go negative set or negative 7 because it goes minimum first for the x, comma 7, and then we could count by ones. Okay, sorry about that, having some technical difficulties. Now let's take a look at my y. And when I did that, we noticed my y wasn't big enough. So a good example here, I could still leave it at minus 10 because I saw the minimum. But I'm also going to exchange it. So I'm going to go, my maximum wasn't big enough, so I put 20, and then I'm going to count by 5s, just so we could count by something. And that's how we do that there, okay? Because I wasn't able to see it, and now when I see it, it's going to be like this, okay? And that's how we do that. And this is like that. So that's everything. Here's a summary of all the characteristics of polynomials. Tomorrow, remember, we're going to share with our groups what we did in this first, and then we are going to continue with the assignment. So I hope everyone did this and actually did their homework. I'll be checking tomorrow, and see you tomorrow.